Howdy and welcome back. We will begin today's lesson with an introduction to lambda expressions. I wanted to go ahead and start out with a definition, which I've taken from Wikipedia. So an anonymous function, also known as a function literal, a lambda abstraction, or a lambda expression, as we will call them, is going to be a function definition that is not bound to an identifier. Anonymous functions are often arguments being passed to higher order functions or used for constructing the result of a higher order function that needs to return a function. The name lambda comes from the work of Alonzo Church on the lambda calculus, a formal system for expressing computation mathematically. Many programming languages are going to have lambda functions, so this isn't going to be restricted to the C++ language. And actually Python uses the keyword lambda when you're going about declaring one. We'll see here the syntax in C++ might not be as friendly, but it is, once you get the hang of it, it's not so bad. So we'll go ahead and introduce that in the subsequent video, but let's kind of continue talking about lambda expressions more generally. So in the C++ programming language, lambda expressions are going to be a convenient way to create function objects. We're going to see it's kind of a syntactic sugar of sorts. They're not going to bring us any new expressive power to the language. Everything they can do, you could have done by hand, although with a bit more typing. And we'll see kind of how the compiler interprets them and kind of the implications thereof as we're moving forward within today's lesson. But to, I don't know, motivate the topic a little bit more, without lambdas, the standard template library algorithms such as find if, which I believe I presented in a previous functional style programming lesson video, remove if, which I'm pretty confident some of y'all have used in one of some implementation. I know there were questions about it on the forum, although I haven't formally taught it, but I think if you were to look up the API, how it's to be interacted with, by the end of this lesson, you'll be quite clear on its different components. For instance, it uses iterators and some criteria, which we can specify actually with a lambda function. Similarly, for countif, these STL algorithms tend to be used only with more trivial function predicates. So what we've kind of seen to this point, function pointers, function objects. However, with lambdas, the use of these algorithms with non-trivial conditions becomes almost trivial. And we'll again see some examples on that kind of reinforce this notion here. The same that we've just mentioned about the reference algorithms is going to be true of algorithms that can be customized with some sort of comparison functions. Sort, the nth element and lower bound would be an example of these, who you can actually pass to them a lambda function or a function pointer or a function object that dictates how some sort of comparison is to be formed, similarly to how our filter function took a function that determined the criteria or the specifications for the filter operation. We're only going to scratch the surface on their application, but we will mention that they're also useful as context-specific functions for one-off calls. So a lambda expression is just an expression. It is a part of the source code. If we go ahead and look here at our copy if, and I went through this a bit, I believe in a previous lesson, let's just look at the arguments being provided to it. We have an iterator that's communicating the beginning of the collection of objects, which this function will consider, and then an iterator to one past the last element within that sequence provided to us by the standard template library vectors end behavior. We then see this back inserter, which is essentially going to take the movie object under consideration and insert it into this filter movies vector, provided it meets some sort of specification. The criteria that we're using here is being passed in by a lambda function. I don't expect y'all to know its components just at this time, but we are going to decompose this in the next video. But what this is essentially saying is that each movie, or how it's going to be used within copyif, is each movie is going to be passed to this anonymous or lambda expression. And then as with kind of our other functions, the body of the lambda expression, so this returned M release year less than 1990, is going to be the criteria that will determine whether or not the current movie under analysis is going to be copied or inserted into our filter movies vector. So provided this expression returns true when a movie is being evaluated, that movie would be a part of the filtered movies collection. Otherwise, we'd continue on and consider the next movie. And we'd consider on in both cases because we're considering each element within the collection one at a time and only pushing it to filters movies, provided the function predicate, the function object, or in this case, the lambda function passed into this copy if standard library algorithm evaluates to true. So a closure is going to be a runtime object created by a lambda. We'll get into this a bit more. We'll see here as we're moving forward, it can hold copies of or references to captured data. In our example, the closure is the object that's passed at runtime as the fourth argument to standard template library's copy if. So you can kind of look at this at compile time. We have a lambda expression, a closure class, depending on how you want to look at it. But after compile time, this is actually going to become what's known as a closure, and it's going to be the object that is passed at runtime to this standard template library algorithm. So with that, hopefully this introduction is kind of motivating maybe what's to come. Hopefully you see where we're going. If not, though, understand that after we begin decomposing the different parts of the lambda expression and then begin looking at what the compiler is actually doing to generate that closure, and then once we see it live and in action with our filter movies, I'm quite confident that all of this will come together and you'll have a relatively strong foundations on the utility of how these can be used. So with that, I'll see you all in the next video.